Okay, so welcome back to our class in statics of rigid bodies. So we have already dealt with the definition of the statics of rigid bodies or the engineering mechanics as a whole. And now we will be talking about fundamental concepts. Because when we are talking about this course for the whole SEM, you should first know those fundamental concepts in engineering mechanics. Siguro, inig-abot ninyo sa midterm mo nyo, wag mo kibaw sa mga fundamental concept, maglisod mo. Promise. So that is why we should first deal with the fundamental concepts before we will go to some other complicated nga mga concepts. Okay? So, what are our learning outcomes for this lesson? So we have here 3 objectives nga dapat natong ma-learn ani nga lesson. First is to know the most used quantities in this course. So we have to know the basic quantities used in statics of rigid bodies. We should also understand what are the idealizations used in statics of rigid bodies. Okay? Kay daghan tag mga panggamiton ng mga idealizations and importante na kayo as we go through this subject. And later, we'll also understand Newton's 3 laws of motion. Okay, so I guess you all naka-familiar mo anang 3 laws of motion, and I hope that you will be able to recall all of those things when we talk about them. So these are the most used quantities of statics of rigid bodies. And take note of this, these are only 4 quantities, and maora dyan ang balik-baliko na to o gamit ng mga quantities throughout this course. Okay? So first is the length. Now, what is the length? What is length? Unsa naman pag-define ng length? Basically, length just actually means the quantity used to locate a position of an object, a point in space. Okay? So, para ka makahibaw sa location sa usa ka point, then you should know its length. Sounds tricky, right? And also, it also describes the size of a physical system. So, for example, this case. To know the size of this case, then imo siya, kung makahibaw ka sa length ani, then maka-imagine na kaunsa kadako ng kaninga case, right? Sige. So, ingana lang ang length. Time. Well, actually, time is more used in your dynamics of rigid bodies. Pero aton lang ni appeal because naman tay force, and kanang force naman siya acceleration. Kanang acceleration naman siya time. Aton lang i-appeal. Okay? So, time is just actually, si definition ani? Time is actually the series of events. So, di ba, for example, makahibaw ka sa Saan pag-example? Saan pag-example of time? Alas 3 sa buntag. Huwag kayo bawon sa pag-example of time. Kaya bawon na mo, ana. These are the series of events. Basta mo lang na. Oh my God. Okay. Next. Next quantity that is very commonly used in statics is mass. Oh, importante dyan ni. Kanunay dyan ni gamiton. Unsa man yung mass? This is actually the quantity of matter. Unsa man ang quantity of matter? We will talk about that later on. Kaya ato na dig in unsa jud definition sa mass. Kay probably apel pod ko sa una na ako yung mga misconceptions about mass, and let's talk about that later on. Okay, so next is force. So we have already defined what is force previously. So again, it is the push or pull of an object to another object. Okay, again, I did say earlier that we have a lot of idealizations in statics of rigid bodies. Unsa nang idealization? Mauna ang kanang mga assumption, kanang mga ato gi-assume nga ang kanang butang is perfectly like that. Nga murag concept lang siya, more siya imaginary nga situation. Nga na ang ideal. Okay? So first idealization is objects are usually considered as particles. So this thing is an object. This thing is an object, this thing is an object, everything in this table is an object. But here in statics of rigid bodies, we usually assume that these objects are just particles. When you say particle, unsa man na, they are just a single dot. Okay? So, for example, kani nga box, nag-push siya ani nga box, then usa ka particle nag-push siya another particle. Ngana lang, ato lang gi-assume nga ang objects. We are neglecting the size of the object for some instances, but not all instances, okay? Sige. Another, ako na nagayon kaganiha, that another idealization in statics of rigid bodies is we consider all objects to be rigid. Again, rigid means it does not deform, it does not break, it does not change shape. So even though nipis kaya nga mga butang, even though you imagine a sponge, when we are talking about sponges in engineering mechanics, we assume that sponge to be unbreakable. Ay, di man na ma-break ang sponge. Undeformable. Okay? So next, our third idealization is that all forces are just exerted on a single point of a body. Unsay pasabot ana? Ang atong mga forces, sige. So, for example, I have this chalk box and ako agi-push ang akong chalk box using my hand. Okay? So, when we assume that all forces in this course are concentrated forces, then the force nga gi-exert sa akong kamot diri sa ani nga object is just at a single point. Okay? Single point lang, literally nga single point. Mura siya dot. Pero in the actual, nagod ni area ang akong finger, di ba? Na area akong finger. So, naadjud ni siya distribution sa force. But in this course, we will assume that all forces are applied at a single point. Okay? Ganto lang. Next. So, those are the three idealizations usually used in statics of rigid bodies. And take note, applicable to sa tanan na to nga mga applications ani nga subject. Okay? So, mahumaning nga subject, forget about those assumptions. Kaya naan na po tayo ang mga assumptions later on sa sunod nga mga subjects ninyo. Okay? So, let us also first review, I guess, because you are already familiar with this one. Let us review about Newton's three laws of motion. Diba? Familiar mo na. Unsa to three laws of motion? First law, second law, third law. Engineering mechanics is actually founded on these laws of motion. So these laws of motions are very important in the application of this course. And tanan atong mga discussions diri makita ani nga three laws of motion. Okay? So these are very important. So you should take note and you should be able to understand it by your heart. Diba? So, our first law, Newton's first law of motion. Can you remember what is that? A particle originally at rest or moving at a constant velocity tends to remain at that state provided that there are no unbalanced forces acting to that particle. Unsa may pasabot ana? Okay. So ato figure out unsay pasabot ana. We have a body, let's say this one is a particle. Nara siya diha sa atong surface. Okay? So this particle will tend to remain at rest or will tend to move at a constant velocity provided that particle is not subjected to unbalanced forces. What are unbalanced forces? Naa day tay forces nga balanced? Naa day tay forces nga unbalanced? Mao na ang atong istorya karon. Unsa man na mga balanced forces? Ang kana atong balanced forces actually na siya equation. The equation that is applied to that is the summation of forces. It should be equal to 0. So, unsay pasabot ana? Naay force diri, naay force diri, naay force diri, naay force diri. And para mo equal into 0 na siya, dapat inig-add nimo aning force 1, force 2, force 3 ug force 4. Dapat ang iyang sum is equal to 0. Okay? So, how can that be possible? Oh, let's imagine again this chalk. Nagbutang kog force. Ni-move siya kay ni-accelerate siya. Pero ako man siya gibutang og force dire. So ni balance siya. Okay? Okay? Nag-apply kog same force sa other side. That's why it's not moving. Okay? Nga na lang. And also, we can apply it kaning chalk nga gibutang lang diha. Wala siya nag-move. Pero makaingon ko nga balanced ang forces dire. Nga naman. This chalk is actually pushing the table downwards. O sige, sa pag-push atong chalk by its weight. But now, it is balanced. Why? Because your table is actually pushing your chalk upwards. So, your chalk is pushing itself on the table, let's say on the weight of 10 newtons. And also, ang atong table ni react man, so nag-push po siya og 10 newtons sa atong crayon. That's why it's not moving. Okay? But again, if you are going to apply an unbalanced force, it moves. Okay? So, mao na dira ato ma-apply ang atong summation of forces is equal to 0. If you are going to sum all the forces, it should be equal to 0 when we are talking about static equilibrium. Newton's second law. Unsa man to be? A particle acted by an unbalanced force experiences an acceleration that has the same direction as the force and magnitude that is directly proportional to the force. Ang atong object, ang atong particle, di ba kagani balanced force man to. Pero karon ato siya gibutangan og unbalanced force. Nagbutang ta og force. Okay? And ang kaning atong particle na siya tendency to move at this direction. And ang iyang pag-move ana nga direction is actually, it is not moving at a constant velocity, but is accelerating. Okay? So that is why we have that well-known equation, summation of forces is equal to ma. Diba? So, since if you are going to sum all the forces and wala siya mi-equate into 0, so you can say that the forces is not balanced. Okay? And that is why that object is actually accelerating. It is moving. So, take note, when you sum all the forces and it is not equal to 0, then maka-picture out na kadayon nga ang kana nga object, it is moving. It is moving, pero take note, it is not moving at a constant velocity, but it is changing its velocity per unit of time. Okay? And that is why, ato nag-ingon nga, nag-accelerate na ang atong object. Okay? Take note, put it in your mind. So for our third law, so ganitong third law, actually the third law is the mutual forces of action and reaction between two particles are equal, collinear, and opposite. Pasabot ana. So, for example, you have this wall. Okay? And you are pushing this wall. Diba? Kuya ato pag-push sa wall. So, you are putting a force to the wall. And actually, ang kaninga law is just simply called the law of action and reaction. So, kung nagani action, reaction ang tao. Ato lang apply sa tao po. So, kung magbutang ta og force, ani nga wall, because of law of action and reaction, the wall will also apply the same force to you. Okay? Mao na ang atong law of action and reaction. Those are the three laws of motion. And I hope you already have recalled all of these things. Because, again, this is very important when we are talking about these topics later on. So let's go back sa akong gi-promise kaganihang mass. And probably you have some misconceptions of the concept of mass. Sige, let me give you a comparison. What is the difference between mass and weight? Siguro niingon na mo sa una nga, ang kanang weight kini gravity. Yes, sakto na. Pero let's dig in deeper kung unsa joy difference ana. Diba? We have defined earlier that mass is the amount of matter in an object. So let's say, for example, we have an object. And this object is composed of small matter. Ato'y assume ha nga ang kanang matter lingin na sila. Lingin. So, this object is composed of these matters, these very small matters. And mao na atong mass. It is the quantity of these matters. Okay? Pero, when you talk about weight, actually weight is a force, mass is not a force. Okay? So, mass is not a force, weight is a force. Because nganong ang weight kay force man, it is actually influenced by gravitational acceleration. And it now becomes a force. And when you say weight, nana siya direction. So, ang kaning atong object, kung nana siya weight, move siya at a certain direction. And that is usually going downwards. Kay dira man padong ang atong gravity. It goes downwards with the acceleration given. And in our subject here in statics, we usually use this gravitational acceleration nga widely used, and actually this is determined on the 45-degree latitude of the Earth, ambot nun sana, and the acceleration due to gravity in SI unit, it is actually 9.80665 meter per second squared. Okay? So this is the acceleration due to gravity nga ato kanunay gamiton diri sa atong subject sa statics. When we are talking about Earth, ha? Kay kaning acceleration is only applicable sa gravity sa Earth. Okay? And for English, we have 32.17404 feet per second squared. Na lang. So, ato ni kanunay gamiton nga mga values when we assume our acceleration. You should also remember that mass is actually the ability of that object or that body to resist motion. Say for example, ang kani nga gamay nga object, ton kay gamay ra man siya, makaingon ta nga gamay ra po ni siyang mass. Okay? So ako gi-push ang kaning object. So mo push siya dayon. But when you talk about heavy objects, is it easy to push heavy objects? No, because heavy objects dako na sila og mass, and kung dako ang mass, lisod mag-apply og motion ana nga object. Okay, lisod i-move ang kanang object. And again, it is because of the influence of mass. To wrap this up, we have already talked about the different quantities used in this subject. We already talked about the idealizations that we are going to use in this subject. And last, we also have talked about the three laws of motion. Okay? And I hope you have already recalled all those things, and karon mabutang na sa inyong mga alimpatakan para magamit na nato throughout this sem. Okay, so I hope you have learned a lot in this lesson, and we still have another lesson later. So stay tuned.